Hello, everyone. Welcome. My name is Stefano. I'm a product manager at AWS, and specifically, I work on Amazon API Gateway. First off, I'd like to say thank you for coming. I am keenly aware that this is the last session of the day. Not only that, it's the last session separating yourselves and beer at the pub crawl. So thank you for taking the time. Hopefully, this will be helpful for all of you. I'd like to open another parenthesis before we start to thank the amazing ecosystem of customers, partners, and developers that surrounds AWS, because all that we're doing would not have been possible without them. And I'll give you a couple of examples. When we launched API Gateway, we just a couple of days ago, one of the AWS partners, 3Scale, another leader in the API management space, released a version of the toolset that allows you to create a developer portal, manage authorization and administration of your users that works with API Gateway. And we've also seen many open source frameworks. I'm sure you've heard of the JAWS framework come out to speed up development of APIs with API Gateway and Lambda. So thank you. An applause should be for yourself. But let's get started. The session today is all about building APIs with AWS. And what we're going to look at is first, what is this new model that we are proposing, this fully managed model, where we take care of your infrastructure. And then we're going to go deeper, and we're going to use a practical example, an actual application that we've built to demonstrate how API Gateway works and integrates with the rest of AWS. So we're going to use Lambda to build our backend logic. We're going to use Amazon Cognito to generate credentials and authorize calls to our backend. And then we look at how this is integrated with the client SDK. We've built an iOS mobile app to show this. So the first thing we want to look at is this new fully managed model. You'll see that it's a fairly simple chart when you look at it. It's just client, we use a mobile app in this case, but it could really be another service, a website, anything you own, talks to API Gateway, that then talks to Lambda, and Lambda talks to anything else. It's much simpler than what you're used to see and what you're used to build yourselves. And it's because that complexity is taken over by us. And if you look at the zoomed in section down there, that's how API Gateway works. Requests first come in through CloudFront. So we use a global distribution with CloudFront to accept requests through all our 54 points of presence around the world. Requests then go to API Gateway in the region over the internet. And then API Gateway processes them. And it can either read the cache, if you've provisioned one, and responds without pinging your backend, or run your logic, whether that is an HTTP endpoint that you own, hosted on EC2 or anywhere else that is publicly accessible on the internet, or a Lambda function. So what I want you to take away from this session is first that using API Gateway plus Lambda means that you have no infrastructure to manage, and that scaling is incredibly simple. And we see this particularly with our mobile customers. Going from number 80 to number 2 in the App Store takes 2 minutes. And the spike in traffic, the velocity at which you have to reach the scale to handle that, is not something that you can do easily yourself. And this is where managed services such as API Gateway and Lambda come in, because we have that scale and we can handle your demand. Second is that security is important. Duh. Well, we talk with a lot of startups, and very often what we hear is, yes, security is important, but we need to get to market. So we'll worry about that when it becomes a problem. And we don't think that world exists anymore. Given everything that's been happening, security should be a top priority from the get-go. And so we're going to look at how you can leverage all of the work that we've done at AWS to secure our infrastructure, and how we've productized it and made it available to you so that you can leverage it easily. And finally, we'll look at how to automate the workflow, importing Swagger definitions so that you can keep them in your source repository. And incidentally, on this, I need to open another parenthesis about the ecosystem. If you know, we've published the Swagger imported utility on GitHub. And a short time after, the good folks from MuleSoft sent us a pull request that added support for RAML to that utility. So RAML is coming very soon. It's just a matter of us accepting that, and it's coming. To build our demo, we are going to use these 4 services. I mentioned them earlier. The first is API Gateway. This is what hosts our APIs and what defines our contract with our developers and end users. Lambda will run our application's logic. And then Amazon Cognito is in charge of managing the end user identities and delivering credentials that secure access to our APIs. And finally, we're using DynamoDB as a data store. So let's get right to it. And yes, it is another pet store. That seems to be the hello world of APIs. But it is a pet store with a twist. There's 2 separate call flows in our application. The first one is the unauthenticated flow, when we don't know who the user is yet. It just calls our login or registration APIs. And in that case, we will accept requests, authenticate the user against a user database, and then give them AWS credentials. Once they have those AWS credentials in the client, we can switch to our authenticated workflow, which is where the pet store actually lives. And all API requests are authenticated, are tracked against the user, and authorized downstream throughout the AWS services we use. And we'll go into quite a bit of detail on that. And we'll also show you some code of how the application works. So what's new about this new workflow? Well, the first one is, I always hear people saying it's a serverless backend, but it's not serverless. In fact, your application can use thousands of servers. The difference is that you don't have to manage any one of them. We do that. Spin them up and spin them down for you as needed. We'll learn to leverage all of the AWS tools for authorization. As I mentioned, we've done a lot of work at AWS to make sure that we had a secure environment. And we've built all of these tools, such as IAM, to manage policies and access control. So we'll show how our application leveraged these. And finally, we'll look at how we deploy the API. So let's jump right in. The first component in our architecture is API Gateway. That's what receives the request coming in. So for those of you who are not familiar with API Gateway or want to learn more, this is a brief overview. So what API Gateway offers is an abstraction on top of your existing API or your backend logic. And I like to think of it as an interface for developers. You build this interface so that you can later on change the implementation. The contract with the other developers remains the same because the interface is stable. But your implementation can be changed at will. Next is network management. This is something we do a lot at AWS, and we have learned a lot over the years. The first thing is DDoS protection. It's complex. AWS API Gateway offers layer 7 DDoS protection, so malicious request, if we can identify them, and layer 3 DDoS protection. So SIM floods, for example, this is something we absorb and we handle. You don't have to worry about them. And finally, AWS auth. And I go on about this quite a bit, like a broken record, but the big news with API Gateway is the fact that we treat your service, your API, and the methods within your API as if you were an AWS service yourself. So if you're used to working with AWS, you know we have the Amazon resource name, those very readable ARNs that we give you, and they uniquely identify a resource in your AWS account. So every one of your API methods, so for example, the post to /users, will have its own ARN, and you can use it in your IAM access policies. So you can leverage all of the AWS tools to manage the security of your own APIs, of your own software. This is to give you an idea of how API Gateway thinks about your requests. It's a screenshot from our management console. This is the main page you will be looking at quite a lot as you work with API Gateway. And as you can see on the left, we have the structure of the API. This is actually the API we are using for this demo. And on the right, we have the method editor. There we are looking at a specific method that posts to /users. There's 4 steps in a request lifecycle in API Gateway. First is the method request, which is where you define what the body of the incoming request should look like, which parameters, query string, headers it should accept, and how it's authorized. This is the contract with your end users. This is how you define the public-facing part of your API. Once that's passed, we go to the integration request. At that step, you will be able to modify the incoming request, transform it however you want before it's sent to your backend. You can also pass it straight through if the interface looks exactly the same as your backend expects it. Once the request is processed by your backend, it comes out, and you have the integration response step. That is where we capture the output coming out from your backend, and you get another chance to transform it in case you want to change it before it's sent back to your end users. And there, you also map it to HTTP status codes. So for example, in Lambda, there is no concept of status codes, but you will be throwing exception, perhaps. So that's where you trap those exceptions, and you say, if the exception is this, you should return a 400 or a 500. And we'll go into this during our demo and samples. And finally is the method response, which is, again, the definition of the contract with the end users, what the API looks like, what it returns. And I've drawn that vertical line because the way I think about it is that everything on the left, method request and method response, is the public-facing part of your API. It's what you should strive not to change. It's your stable interface. And everything on the right, what we call integration, is almost already part of your backend. It's where you transform and tell API Gateway how to interact with your backend. And my clicker clicks. Excellent. So this is the API structure from our demo. It's very simple. We have the users and login resources. This is what we use to register and authenticate users. These require no authorization. They are unauthenticated methods. And then we have the pet store itself, which has a /pets resource and the /pets pet ID resource where you can get the specifics of a pet. Now, before we go and actually look at the code, I want to show you the application very quickly to see what we'll end up with. You'll forgive me, I'm not exactly a designer, so it doesn't look particularly flashy. But the first thing it does is ask me for a login. This is because it doesn't know who we are. So we're going through that unauthenticated flow. What the application is doing now is spinning up my Lambda function, logging in, ask for the list of pets, and when I click, it gets individual pets. Very, very simple, but there's quite a lot going on behind it. So let's get back to it and see how it's built, both the application and its backend. The first thing we're doing is defining that API structure we've just seen. I'm using Swagger for this sample. And I'm showing you this slide with a snippet of our Swagger code because I wanted to draw the distinction between the various sections. If you remember, when we looked at the screenshots, we had those 4 boxes. And as you can see in the Swagger, you can clearly identify that the top part, /post to /users, identifies which method it is. And then we have a definition of what the API receives, which parameters it accepts, and what it produces. This is our method request. And then we have a custom extension that we've added, the X Amazon API Gateway integration. That is where you tell API Gateway how to interact with your backend. That is where you define your 2 integration boxes. And finally, you have the method response, so your public definition of what the 200 status code looks like and what the 400 will look like. So let's go through the actual Swagger definition file. Can we all read the text, or should I make it bigger? Good. OK, so it's very straightforward. The first thing we're looking at is the post/users, our registration API. As you've seen from the slides, it consumes JSON, it produces JSON, it receives a body object with a username and password for the new user, and then it integrates with another AWS service. As it's very clear to see from this, another very friendly, readable URL, it's a Lambda function we are calling. This is the invocation URL for the Lambda function. And then we have this credentials field. And here, we're specifying a role in our AWS account. And that is because this API call is one of the unauthenticated calls. So we don't have credentials coming in. We don't know who the user is. So when API Gateway receives the request, it needs to assume a role in your account to be able to invoke the Lambda function. And I'd like you to look at this in contrast to one of the authenticated requests. So let's go and look at the pet store. For example, the API to create a new pet, the post/pets. You will see that the first thing, we have a new authorization tag that tells API Gateway that we are using IAM to authorize this request. And when we go to the integration, you'll see this role. There's nothing strange here. This is something that's always been available. It's a bit of IAM witchcraft. And what we're telling API Gateway here is that we want to take the credentials from the incoming request and pass them on to Lambda. So run the Lambda function with the same credentials of the caller to give Lambda the exact same permissions that you have assigned to the end user when you produce the credentials for them. And then as we go on, you see that in the integration definition, we have a space where we transform the incoming request. And we'll go into more details of how this works and why I've done it this way later. And how we map the responses. As I said, you may throw exceptions. So we want to make sure that those are mapped to the correct HTTP status code. So we recommend you use something like Swagger or RAML to define your APIs, because this gives you the ability to keep the API definition in your own repository. It's yours. You own it. You can version it. You can work on it as much as you want. And API Gateway should purely be the tools that run it. You just deploy it to API Gateway. Additionally, both Swagger and RAML provide a lot of tools, open source tools that can work with API definitions to generate documentation or even generate additional SDKs. So if you already work with Swagger, you can import the definition in API Gateway and then reuse the same file to generate documentation, generate SDKs, and anything else you may need. So it's not too intrusive into your workflow. It's just one additional step deployed to API Gateway. And as you can see, it's a one-line command to get the entire Swagger file into API Gateway and deployed. So now we've defined our API. We have that definition, the shape of it. And the next thing we need to do is route requests, decide how to handle them. As I mentioned, the applications logic lives in AWS Lambda. This is a service that needs little in the way of introduction. How many of you have worked, tried, played with Lambda? Yeah, that's what I thought. So Lambda is our stateless, trigger-based compute service. What that means is that it gets rid of all of the boilerplate code that you're used to writing around it to, stand up your web server, accept requests, and do all of that. You simply write your application's logic, upload it to Lambda, and we run it on demand. And these events can be triggered by a file being uploaded to S3, a row being modified in DynamoDB, or in our case, a request coming into API Gateway. Another great thing of Lambda is that you pay only when your code runs. If your code runs for 100 milliseconds in a month, you will pay for 100 milliseconds. The rest is on us. So it's a great model. So how does our application work? You may have noticed when I open IntelliJ that I've written the application in Java, and it compiles down to a single jar. And what that means is that I have a single Lambda function that handles all of my APIs. This is not necessarily best practices. This is something I've decided to do. This is how I prefer to work because of course, we need to update Java. Because I'd rather work with a single Lambda function rather than multiple functions and updating them. But as I said, any approach is perfectly valid. It's purely how you prefer to work. So how I've done this, if you remember when we looked at the Swagger, that was that little snippet of request transformation when it comes in. And you can see the example down there, my template. What I'm doing there is telling API Gateway that when a request comes in, I want to generate this new JSON object. The first property is the action, where I have hard-coded the name of the class that I want to run for that request. And then I have a body property, where I simply tell API Gateway to read everything that's come in and just slot it in there. So let's go and look at the code for this. I have a Lambda handler, a single entry point for my Lambda function, which is right here in my request router. This is the Lambda handler. So when I upload my jar to Lambda, I simply tell it to point to request router, Lambda handler, and run this for every single request. So what I'm doing here is parsing the input JSON that's come from API Gateway. Once that's done, it's completed successfully, I read my action object from there. And if you remember, that was the name of the class that I want to execute. And once I have the action object, I simply try to instantiate the class. All of my actions, as you can see them here on the left, implement this interface. So once I've instantiated that class, all I need to do is read the body and run the handle method of my object with the body. And this way, I have a single Lambda function that handles all API methods. So now we have our plumbing for requests coming in. The next thing is what we send back, what goes out. And so as I mentioned, there's different classes, one per method in my APIs. And what I've done is I've made sure that all these classes throw exceptions if something goes wrong. And I've defined a number of custom exceptions in my application, but there's two in particular that I'm interested in. One that I throw if I have wrong parameters coming in, my bad request, that's a 400. And one that I throw if something really, really bad happens and I've made a mistake, and that's my 500. You can have as many as you want. Of course, I've kept it very simple here, just 400, 500, but there's nothing stopping you from defining a 401, 402, 403, as many as you need. And you can see in the mapping there, what I've done in API Gateway is I told it to expect something that begins with bad, then becomes a 400. Something that begins with int becomes a 500. So if we jump back to my code, you see that I have quite a few custom exceptions here. But my Lambda handler function only throws these two. Only throws a bad request and an internal error. And all I've done is in these custom exceptions, the bad request, I've added this prefix. So whenever the exception is generated and the message is spat out, it contains that prefix, bad request. And that's what API Gateway matches. Again, it's not best practice. It was my choice. I decided to implement it this way. It's perfectly valid. You could do it any other way. But now we have the plumbing in place. We can receive requests, run them in the correct class, and generate valid responses or valid exceptions. So what I want you to take away from this is that mapping templates are extremely powerful. I'm doing something very simple here in my sample. I've just created that action and body and just read everything in. But there's quite a lot you can do in mapping templates. You can read the body with a JSON path. You have for loop. You have if statements. And we have a whole set of variables for you to use. So there's the input variable you can see there, which contains all of the incoming requests. There's a context variable that does exactly what it says. It contains the context of the request. So it can tell you who the user is, what's their IP address, what role they've assumed, if they have a role, what's their identity ID, if they have one. Everything that we know about the incoming request, you can read it and pass it on to your backend. And then we also have a utils function that you can see there. And util contains a few utility methods. You can base64 encode content. You can JavaScript escape. You can JSON escape your content as it goes through. And we have a whole page on the documentation with the reference of the mapping template. So take a look, because they're extremely powerful once you learn them. So as I said, now we have the plumbing in place. We can receive requests and respond to them. So the next step is to get credentials to the client so they can access our pet store. As I mentioned, we are going to use Amazon Cognito to get the credentials. For those of you who are not familiar with Cognito, Cognito is an identity management service. It basically creates a unique, stable identifier for your end user, and this identifier can be associated with a public login, so Facebook, Google, Amazon. We also support Twitter and digits, or with your own user identity, if you run your own user database, like we're doing in my demo. Once you have the stable, unique identifier, Cognito helps you retrieve AWS credentials for them. These credentials are temporary. They only last for 1 hour, and they are associated with the user, with a specific identity ID of the end user, and with a role in your AWS account. So that's what regulates what the credentials have access to. And Cognito can also save data for the user and synchronize it across devices. We are not going to use this feature in this demo. We are purely concerned with creating identities and getting those credentials back. So the details of the unauthenticated flows, we have registration and login. The flow is fairly similar. They check the user credentials, or create the user credentials in our DynamoDB table. And once the user is authenticated, they make the call to Amazon Cognito to get those credentials. This is the flow of how that call works. The client will make a post to log in with a username and password. The first thing we do in our Lambda function is authenticate against DynamoDB, verify this username and password. Once we have verified this, we start the Cognito flow. So the first thing we'll do is ask Cognito to give us an OpenID Connect token and the identity ID for the end user. And I'm paraphrasing here, but what we're saying in that API is, hey, Cognito, I've authenticated this user. I trust them. Here's my unique identifier for them. Please give me an identity and token. Cognito responds with those two. And the next step in the flow is to get the credentials. So we send to Cognito back the OpenID token, and Cognito will trade that token for AWS credentials and return them to our Lambda function, which then sends them back to the client. So that I'm going to take you through that login action in the code. Is the login demo action. So this is what runs when you log in. The first thing is read the incoming request into our model, into our bean, and then we do some basic validation on it. And if something's wrong, we return a bad request, which translates to a 400. Once that's done, we get our DAO object, and we load the user from DynamoDB, get user by name. We found the user. We then go ahead and authenticate it, so verify the password they've attempted to log in against the one I have stored. There's a bit going on in there, but I'm going to skip because it's not the topic of this conversation. Once they're authenticated and we are sure it's them, then we start the Cognito flow. I have two objects here that wrap this. My user identity, where I store that token and the identity ID, and the user credentials, which is simply a wrapper on top of the AWS credentials object, the access key, secret key, and session token, if you're familiar with it. So the first thing I do is make a call to get the user identity from Cognito. And we can go and look at this code. It just uses the standard AWS Java SDK, where we have this very simple API called the get OpenID token for developer identity request. And we run this with an identity pool, which is the main entity within Cognito, and an identity ID, if we already have one, if we've received it before from Cognito. If we don't have to send it. And we also tell Cognito that our unique identifier for this user is the username. It could be anything. So long as it's a unique string, alphanumeric string that identifies the user for you, you can send it to Cognito, and it will run with it. Cognito responds to this with an identity ID, which is just another string, and the OpenID token. So once this step is done, we save the identity that we retrieved into our user object, and then we go and ask for credentials for that user. So let's go into this function. And it's, again, very simple. Using the standard AWS Java SDK, I have the get credentials for identity request, where I send the OpenID token that Cognito has just given me. And Cognito responds to that with an access key, a secret key, a session token, and an expiration. And you see that I'm wrapping these in my own user credentials object. And I'm doing this because I'm then using this in a special way on the client, and we'll go through that. The whole purpose of this loop I'm doing is because developers that interact with my API shouldn't need to know that I run on AWS or that I want to use AWS credentials. It's not their concern. So I'm hiding this away from them, and I'll show you how I do that on the client. But once that's done, we have the credentials. I simply build my response object, and what I'm sending back to the client is identity, token, and credentials, and send it out. And that's it. Now we have credentials on the client. So our next step is to authorize API calls to our pet store. This is just a refresher of the API structure for the pet store. We simply have the /pets resource and the pet by ID resource. Pretty standard REST implementation. Post creates a new pet, get gets the list of pets, and the other get with the ID gets you the details of a pet. What's special about this is what I told you earlier, that in API Gateway, I'm configuring the API to invoke the Lambda function using the credentials of the caller. So those credentials that I've just generated in Cognito for the particular identity ID are getting passed on. And this is very important because that means that you can use IAM roles to define what the user has access to. This is an example of a role for this application. It's very straightforward. It's very simple. It just tells the IAM that the user can access DynamoDB and can invoke the Lambda function, and it can call API Gateway. And I'm limiting this to a particular set of resources. Now, this is very powerful because it allows you to separate the concerns. Authorization is centralized in a policy. Your code doesn't need to know about it. And I've fallen into that trap many times myself. It always starts with a little if on top of your code, saying if the user is this, then don't allow it. And 2 weeks down the line, requirements have come in, product managers have meddled, and you have 2 pages of spaghetti code that introduces one bug per line. So it's very important that to get rid of that yak, you want to centralize this in a single place. But we can take this one step further because this policy is very simple. It just says, yeah, I can read from DynamoDB or I can write to DynamoDB. But there's quite a lot more power in IAM. Fine-grained access permissions. I have a sample policy there at the bottom that specifies a condition. And that condition, I'm telling DynamoDB that the user is allowed to access the row only if the leading key, so the hash key, the primary key of that table, is equals to the identity ID of the caller. So what does that mean? That means that if someone finds a way to cheat your code, somehow tries to get your code to read somebody else's data, the call will come through to API Gateway. API Gateway will pass those credentials on to Lambda. Lambda will use those credentials and try to call DynamoDB to read the data that doesn't belong to that user, and AWS itself will drop that call. You don't have to worry about it in your own code. You don't have to write that little if. So it's extremely powerful, and it's very pervasive. Every step of the way, each service checks against that policy. And this is where you want to get to. This is the world where we want to get to, where the concerns are separated, authentication is centralized, and it's present at every step of the way, even in the database itself. As I said, delegate authorization and authentication. It's very complex. We do it reasonably well at AWS. Let us help you. Centralize this, and we've built all of the tools around it. So when we produce credentials, or when you set up roles, we also have all of the APIs that you need to disable a set of credentials. Even though they last only for 1 hour, the alarm sounds, you can just switch them off and lock them out. So there's a lot of power in these tools. So we're nearly there now. We've got the credentials. We know how to authorize calls. And now we need to get to the client part. So how do we handle those credentials on the client? The first thing is that API Gateway can generate client SDKs for you. Based on your API definition, we will produce an SDK that contains all of your methods and all of your objects. So in this sample, you can see I'm making a get to the /pet resource. I know it's Objective-C. Many people are fans of Swift. I haven't gotten to it yet. I promise I will. But the important thing here is that you've got all your models generated and all of your methods easily available. As you can see here, all I'm doing is calling the get to /pet. The response is automatically deserialized into my object, and I can just pass it on and start looping over it. It makes my client code a lot simpler. But the next topic we want to cover is those credentials. As I mentioned earlier, I'm wrapping those credentials into my own custom bean before I return them. And I'm doing this because I don't want my users to know, or my developers to know, that I'm using AWS. They shouldn't have to. There's an object that comes with the client SDK, and it's called the AWS Credentials Provider. The client SDK uses this credentials provider anytime it needs credentials, either because it doesn't have them yet, or because the ones it has are expired. So what I've done in my application is built a custom implementation of this credentials provider. I work for AWS, so I've picked a short name as well, APIG Session Credentials Provider. And it implements a single method, refresh. This is what the client SDK calls. And if you can see my refresh method, all I'm doing is loading a set of cached username and password. I'm using the keychain in iOS, and making my login call using the client SDK. That will return AWS credentials, and I make them available to the client SDK. So this is a very elegant way to load credentials, because as far as developers know, they only need to give me a username and password, and the credentials are lazily loaded only when they're needed, because the client SDK will not ask you for credentials unless it's about to make a call that requires credentials. So let's take a look at this. in Xcode. Is the font big enough for everybody? So the first thing we do in the app delegate is call this method that sets the default configuration. And what I'm doing here is loading my credentials from the keychain. And then I'm creating an instance of my session credentials provider with that set of credentials and telling the SDK that this is my default configuration. If we look at the credentials provider, it's a very simple implementation of that refresh method. I'm simply loading the credentials I have here and making that login call, as you've seen in the slide. So let's take a quick look at it as it runs. Let me expand this. So it started now. It's loading the list of paths. If we go to a log, you see that the first thing we've done, the first thing my application has done, is call my get paths, because that's my concern. I have that list. I need to populate it. As soon as I made that call, the SDK itself noticed that it didn't have credentials. And so by itself, it called my refresh. It did the login call. And as soon as it had credentials, then it proceeded to make the get paths API. So if I go back to the application now, and I load a specific path, you'll see that there's no login call. It already has credentials. They are valid. So as I said, this is a very elegant way to manage credentials and lazily load them only when they're needed. So using the generated SDK, obviously, it knows how to sign requests. It's important, although you could sign requests yourself. You simply use the AWS signature version 4. It's an open protocol. You can go and read the documentation on the AWS website. But again, it's some of that boilerplate code that you don't want to have to write each time. So the generated SDK does that for you. Another example of boilerplate code is handling throttled requests. You can ask API Gateway to throttle traffic to your APIs. If, for example, your backend can only handle 500 RPS, you can tell API Gateway to only send 500 RPS, and all the other requests are dropped. And they're dropped with a response of 429, a response code of 429. That's what we use for throttling. And the generated SDKs already know how to handle that. So if they receive a 429, they will do what we call exponential backoff. So they will wait 100 milliseconds, try again. If it's another 429, they will wait 200 milliseconds and try again by themselves. So it's a lot of that error-prone boilerplate code that you kind of don't want to have to write yourself. And finally, you get all of the objects built together. So just a final recap, API Gateway plus Lambda. That is the new model we are proposing, where there's no more managing of infrastructure for you. No matter what the velocity at which you need to achieve your scale is, we do that for you because we already run at that scale. Security. We've done a lot of work at AWS, and because API Gateway treats your services as if you were an AWS service yourself, it's time to make the most of these and leverage them. And finally, we looked at the Swagger definition. With those files, we can automate most of the workflows, and more importantly, the workflow remains in your hand. You own that file, it's in your repository, you can work on it, you can version it, and just import it and deploy it when you need it. So if we have some time left, I believe we do, any questions from the room, anything that we can clarify?